Today we are going to cover the topic functions. I'm going to define a function for us. A function is any mapping that takes an input value to its output value. So this is basically what a function does. We have got an input and we have got our output. And a function takes this input value to its output. This input, at times we give the input names. It can be X, which we are so used to, but it can also be called S. It can be called any small letter that you think of. And then most of the times we use Y for our output values. I'm now going to look at a proper function. A function can be written as f of x is equal to x squared plus 2. That could be a function. So we are putting in our x values and we are getting our output, which will be our y values or whatever name it is being given. So our input values are, for example, 2. 2's output value will be 6. 5's output value will be 5 squared plus 2, 27. And 7's output value will be 7 squared plus 2 is 51. So that is what a function does. And we have got the new notation. It says that f is such that x is mapped onto x squared plus 2. This is the new notation. This is the notation that we will find being used in some of the questions. So we must be able to recognize it. But in general, we are basically looking at our old self where we said y is equal to x squared plus 2. But remember, we can also have other letters to represent our functions. It's not only x and y and f that we use for our functions. Examples of functions are as follows. I'm going to give you examples of functions. Examples of functions are, we can have a function written as g such that t is mapped onto t cubed minus 1. You can also have a function written as m such that L is mapped onto square root of L divided by 3. That could be another function. Now I'm going to look at the properties of functions. Now I'll start off with giving us some 4 functions. K such that t is mapped onto 2t squared over 3. Another function will be p such that t is mapped onto t minus 3. And then the last one, I'll call it m, such that t is mapped onto t 3t minus 2. So I've got my 3 functions. They are k, p, and m. But in your mind, if you prefer, these functions will be looking like this. this is k of t is equal to 2t squared over 3. This one is p of t is equal to t minus 3. And the last one is m of t such that a t is 3t minus 2. So you can be looking at these functions like this so that it's easy for you to see. Now, we would want to look at the properties of these functions. The first property is you can actually add functions. I'm going to add kt to pt. These two functions can be added together, and what do we get? We get 2t squared over 3 plus t minus 3. So there we are. Now we have our addition of the two functions. We can multiply fractions. We can multiply functions. So mt multiplied by pt. And that is equal to 3t minus 2 multiplied by t minus 3. And this gives us 3t squared minus 2t minus 9t plus 6. And that finally gives us 3t squared minus 11t plus 6. So you can actually add your fractions, you can multiply them. The next property is you can actually subtract your functions. You can subtract your functions. I'm going to subtract our functions. I will start off with mt minus pt is possible. So this will equal to, my mt is 3t minus 2 minus in brackets my t minus 3. And this gives me 3t minus 2 minus t plus 3. And that gives us 2t plus 1. So when we subtract, it's possible to subtract these functions. We are going to look at the next step. We can actually divide them. We can actually divide our functions. For example, kt can be divided by pt. And at times we will not be able to simplify it. So this will equal to our kt. I want to pick up our kt is 2t squared, 2t squared over 3. We want to divide it by our pt, which is t minus 3. Please take note, division changes to multiplication and you divide. So this is over 3 multiplied by 1 over t minus 3. And to simplify this, we get 2t squared over t minus 3. So we can play around with our functions. I'm going to move to the last property of fractions, which is the fact that you don't always have to draw an input diagram and an output. You can find an output for a specific value. You can actually find an output for a specific value. For this, I'm going to move on and give you a new two new functions that we will work with. If we will let our function, we will let f of x equal to 4 times 3x plus 1 all squared plus 5. This is our function, and it could also have been written as f of x such that x is mapped onto 4 in brackets 3x plus 1 squared plus 5. So now we can be asked to find f of 2. What is f of 2? We are saying substitute where we have x by 2. We are inputting 2 into f of x. So we will first multiply it by 3, add 1 to it, square it, and then multiply by 4. Finally, add 5. So this will equal to 4 in brackets 3 times 2 plus 1 squared plus the 5. And that will give us 4. 6 plus 1 is 7 squared plus 5. The result is 4 times 49 plus 5. And this will give us 196 plus 5, giving us 201. So that is the output for 2 into that function. I will move on and give you another example. We are going to look again at another function. This one kind of simple. If we have g of t is equal to t cubed over 10, what will g of 8 equal to? G of 8 will equal to 8 to the power of 3 over 10. And that's easy. It's 64 by 8. And that gives us 2 carry 3, 48, 51. So it is 512. You are required to use your calculator. If you are doing ZIMSEC, you are not to use your calculator. But if you're doing Cambridge IGCSE, you use your calculator divided by 10. And that gives us 51.2. Now we are going to move on to the next aspect, which is our last aspect. It is possible for us to be given the output, and then we are asked to find the input. Let us look at a function that I'm going to call h. A function I'm going to call hz. This function is equal to 5 minus x squared. So if I am told that h of some z value is equal to, so we will let h of z equal to minus equal to minus 44. The question is to find, we are to find our z. We are to find z. So we go back to the function and we say it is equal to minus 44. So instead of hz, we will put minus 44. So minus 44 is equal to 5 minus x squared. So we can now solve for x squared. I'm going to take x squared to this side, 5 plus 49, and that gives us x squared is equal to 50, is equal to, sorry for that, this is a 44. So it's 5 plus 44, which gives us a result of 49. So our x is equal to plus or minus 7. So we actually have two values of z that we can put in.